Hello and welcome again. In this session I would like to talk about Qt 6 and what's in there for you from the desktop side. Qt 6 has just been released, so this is really like a perfect time to talk about that and then what's in for you there. Overall, when it comes to the desktop is extremely valid for Qt and has been and will be very valuable for Qt itself. One thing I would like to highlight still is also that whenever we are doing some innovations on what we call the embedded side or for the device creation, meaning that being performance updates, memory utilization improvements, etc., those also do benefit on the desktop. The fact that desktop machines these days are more powerful does not mean that compared to other technologies we should also utilize all that available memory, but still you want to have fast performing and as small applications as possible. Having said that, a couple of features from the mobile specific side are reaching out to the desktop these days as well. Specifically when it comes to the user interfaces, how these do look like. So these days you have more like 2D and 3D interactions. You get 3D models integrated into 2D and vice versa. You're having new input methods like touch being now very prominent on desktop applications as well, etc., etc. So Qt needs to take care of that this also is capable in the applications he wants to create. But first of all, maybe let's start with a bit of the history of Qt in itself. In the intro session, I've already been mentioning that Qt is there since quite a while, meaning 1995. And since then we have been releasing quite a lot of Qt versions, with now being Qt 6 being released like a couple of days ago. Within these releases, the lifetime of each of them has been going longer and longer, and now with Qt 5, that has had a life cycle of 8 years already. But even more so, we have been introducing now the LTS, meaning the long-term support releases, which implies that even though Qt 6 is now out in the end of 2020, you will be able to use Qt 5 fully supported until 2023, as long-term support from our perspective means 3 years of longer support. So overall that means that Qt 5 will be there until 2023. But having said that, maybe let's have a look on why there has been a need for Qt 6 after all. Qt in itself is part of the C++ ecosystem, which then again is a big part of the bigger development ecosystem out there. And with Qt we have been able to bring quite some innovation towards these ecosystems. So the whole idea of declarative programming, which is now also being adapted on other programming languages, that is something which we are very proud we have been bringing out to the overall ecosystem. In addition to that, tying in designers into the application or product development lifecycle is really crucial to speed up the development times of products, but also to make all the team members actually work as a team. Having said that, the other ecosystems have not been standing still, and that is one of the reasons why we are now looking forward to Qt 6, because if we look into C++ in itself, when we have been introducing Qt 5, C++ 11 just was started as such. It took quite some time until the major compiler vendors actually adopted to C++ 11. But if you compare that to now, when you have C++ 17, C++ 20, etc., it's actually the other way around, that the compiler vendors already do have most of this upcoming standard implemented in their compilers already. And with that having said, that has brought in quite a couple of language updates, but also programming patterns which has been changed, and that requires Qt to also adapt to that. And then in the broader scale of overall development, there is now also new paradigms coming up like low code or no code tooling, etc. And Qt needs to have some additions or some preparations to easily incorporate these kind of patterns into Qt as well. And with that, we have been coming up with the value proposition for Qt 6, which is summarized as the productivity platform for the future, next generation 2D and 3D user experiences, as well as limitless scalability. When it comes to the productivity platform of the future, what that means is it's not only about Qt being a framework to satisfy C++ developers. Coding is one big asset still, but these days there's many tools surrounding that. That can be for the developer himself, debugging and profiling tools, but also tying in other users or user types, user personas like designers, etc. We also have been seeing that quite a lot of effort and innovation has been happening, integrating developer ops or DevOps cycles, tools in for CI infrastructures, etc. So with Qt 6, we are really aiming to bring the full package towards you as Qt users. I've already been talking about user interfaces, that the 2D and 3D is getting more intermingled between each other. You want to have 3D elements inside your 2D application, but also utilize 2D controls being visible and usable within a 3D scene. And when it comes to the scalability in itself, we have been now seeing that Qt itself already always has been scalable when it comes to running on from low-end embedded hardware up to on supercomputers or cloud infrastructures, but we really want to push this to the next level. One effort in that has also been our parallel program with Qt for MCUs, where we now have been seeing that there is a very big gray area for vendors also to go either MCU or MPU, and Qt itself is not the limiting factor in itself for that. We only have very limited time today to get into the highlights, so I can only provide a very quick overview of some of these. Certainly you will find more information on each of these items, but also more of them on our documentation. We've been doing quite a lot of blog posts, etc., etc. But also please use the chat feature if you want to get into the details of one of these items being discussed in this presentation. First of all, let's talk about RHI, meaning the rendering hardware interface. That's an effort which has been ongoing now since quite some while, but we have been able to do quite a couple of bigger feature additions and updates in Qt 6 to that. So for those of you unfamiliar with the RHI, when Qt 5 has been done, basically the overall consideration was that any kind of operating system, device, whatever out there in the wild is going to base their hardware acceleration on OpenGL. And that statement has been proven wrong in multiple angles, from multiple angles, in regards of that OpenGL itself has found a successor with Vulkan in itself. But also the operating system vendors have decided to focus also on their own solutions. That would, for instance, be on the Apple side, with Metal, but also Microsoft in regards of Direct 3D. So that led to the situation that we have needed to have a layer in between where you could then focus any kind of hardware acceleration, and this is what the RHI project is about. When we're looking at the results so far, they are very promising, specifically when it comes to the upgrade from OpenGL to Vulkan, but also from the demos you might have seen already, you can see that running on Direct 3D or running on Metal is really up to the highest performance possible. In addition to that, we have also been looking into what we call the Qt shader tools, which allows you to create shaders in a cross-solution manner, so that during the build system or during the build times, it will then create the shader programs targeting your hardware acceleration solution. And out of that, we have then been able to also go a bit ahead when it comes to Qt Quick 3D. The overall approach with Qt Quick 3D in itself is that it helps our users to quickly get started creating 3D content or merging 2D and then 3D items or scenarios. The big advantage of this approach is that you have one technology stack or one rendering stack instead of having two different ones. We have been putting in quite some efforts for further features in there in regards of getting started, etc., etc. There is still use cases for Qt 3D in itself, but the approach is rather a different one. So Qt 3D might be compelling for you when it comes to extended and enhanced use cases, very specific ones. But when it comes to Qt Quick 3D, we see that as the best enabler for bringing in 3D content into your existing solutions, as well as getting started as soon as possible. The fact that it's running on one renderer as well is also very beneficial. And to quote Andy Nichols, who said it's not its own product in itself or its own module, it's just Qt Quick, which now supports 3D as well, and that's a much better thing. I will also encourage you to look at the presentation by Andy Nichols, the maintainer, which he has been doing at the World Summit this year. Let's go a bit more into the desktop specific items. Let's start with Qt Quick Controls 2 and desktop styling specifics. I don't want to talk too much about that because I do know that Volker and Richard are going to talk about that quite a lot in the next session. But let me summarize it in that regard, that we have been listening to the feedback when it comes to Qt Quick Controls 2 and its styling capabilities. So far, it has been possible to create your own style very easily, to have a branded UI experience, etc. But we haven't been so much focusing on the desktop specific one to get started creating a desktop application looking native and getting a native look and feel then from that. So that is really an effort we have been looking into, and I encourage you to watch the next presentation by Volker and Richard. Another aspect most prominently known from the Windows users is that we have now enabled support for fractal scaling. Fractal scaling is basically the situation where you do have different kind of monitors with different device pixel ratios. On a closed ecosystem like Apple, that might be very easy to do because you only have 2:1 or 1:1 ratios. But for instance, in the Windows ecosystem, you do have the situation that you have 125% scale or 175% scale, etc. And with Qt applications running then on the desktop, you could pinpoint a Qt application because the scaling in itself has been a bit off for certain use cases and scenarios. So that is something we have been able to fix with Qt 6 in itself, so that now also from a scalability factor, your application looks native. It also helps you in regards of when you're creating your application designs, that you only need to create it once and not take into the account the various kinds of scales. The layouting system and everything will take care of that. When we're talking about specifics for certain operating systems, Qt is known to support like the 95% use cases from a cross-platform manner, meaning whatever you do with Qt, our promise is that it runs on all operating systems, in this context on all desktop operating systems. But there are scenarios where you then need to switch to native specific features. That could be on Windows, the notification bar, that could be other specific items on Android, etc., etc. So with that is what we then, in Qt 5 times, you then needed to have a dedicated module, meaning Qt Win extras, Mac extras, etc., which you then in the build system needed to integrate into your application, where the full cross-platform story kind of broke. So with Qt 6, we are taking a different approach to that, in regards of that all these features are now tied into the QPA backend in itself, and you basically can then have QPA queries whether a certain feature is supported on the target platform you're running the application on. Another big advantage of that is that these are then checked at compile time, which also helps you to speed up the overall turnaround cycle, because whenever you do a runtime check, well, you need to run the application first, then figure out, okay, it's not how it's supposed to work, do a recompile, redeploy, etc., and then go through these circles. Now with compile time checking, like you can also see from other development languages, that is much more compelling and helps you speeding up in the overall development process. One of the key features we wanted to bring in, and we're now going down the stack quite a bit, is binding support for C++. Or we have been summarizing that as new QProperty System in Qt. So the overall idea is that while signals and slots do have their purpose, what we recognize from QML is that binding support is really something which boosts the developer's productivity. And we wanted to bring that feature from QML also to C++. We have been going through various iterations of that approach, but the good thing is that um, with the architecture we've now been choosing with Qt 6 is that it's compatible with the one we have in Qt 5 as well. Meaning whatever we're doing here or whatever you are doing, you can then choose on your own for which properties you want to go towards the new system with binding support, or if it's fully sufficient to stay with the system you currently have with the previous or existing QProperty solution. The big advantage of the new system is especially valuable when it comes to what we call the deferred evaluation, meaning you have a property which is getting changed quite a lot, and then you have one reader which might or might not react to that. In the old system, whenever a property has changed, it needed to propagate that change, and the evaluation chain then has been executed all the time long. While with the new property system, actually that evaluation only happens when it is required, meaning once the reader wants to actually know the current state. And from that explanation, I guess you can understand that this then helps in regards of sparing calculations and CPU cycles, because sometimes you do have sensors or certain data coming in which you're pumping into a property, but you only every now and then need to read that actual value, and that is going to be then helping you quite a lot in speeding up or in regards of performance items. Concurrency is interesting from multiple angles. Well, first of all, comparing Qt 5 and Qt 6, already in 2012 we were talking about multiple CPUs. But back then, I guess we were maybe at a quad-core system or anything alike. I mean, if you look at the desktop system these days, 16 CPUs and 32 threads is it's almost like a regular use case these days. So that has been pushed further and further, and for that, both on both sides, so on Qt, but also when it comes to the overall development patterns, a lot of things have changed. When we're talking about paradigms like continuations, etc., the way how you create concurrent or asynchronous applications has changed a lot, and that is what we also wanted to reflect in our Qt concurrent module. We have been doing quite a lot of updates there, which hopefully will help you being faster in creating parallelized algorithms, scale up your application for whatever runtime there is. The big advantage of concurrency APIs, and then also specifically with Qt Concurrent, is you do have one source code which then runs on a dual core, but also up to the 16 and then more core systems. It's the runtime which then takes care of parallelizing or executing your tasks on as many resources as possible to be done in the most fastest way. Networking in itself also is interesting in that regard, because I mean, the title of this presentation is Ready for the Next Decade. And if you look specifically into networking related aspects, the whole concept of cloud and IoT was something just starting up like 8 years ago. When you look into modern applications, connectivity is everywhere. And it's not just that everyone is still continuing to use TCP or UDP. You do have certain protocols on top of that, which have been over the last 10 years been invented, but also been deprecated partially already again. Even on standard protocols, to say like that, like HTTP, now there is HTTP2 support, etc. And the interesting thing for our networking solution is that we need to have a stack which is capable of providing a certain API set which will scale and last for the next decade, meaning there's probably things coming up over the next 10 years which we couldn't even think of right now. But we want to have an API where you can use that when still in a common workflow, like you are used already. And one of the efforts we have been putting in there is that you're now capable of creating Qt Network Access Manager backends on your own. In regards of those are now plugins, and whenever you have a new protocol or anything like you would like to integrate or add into Qt, that is also possible from a user perspective. One of the examples is also to be able to decouple things or to introduce some kind of deprecation period, is that we have now FTP as a separate plugin, which you then can also turn off if it's not needed for your solution anymore, and that especially without needing to recompile Qt in itself. When it comes to security in itself, we have been seeing quite a lot of security related issues overall in the industry over the last 10 years. Heartbleed is just one example, but even more so. Um, and what we've also seen is that there is more and more solutions now coming up in addition to OpenSSL. So Qt in itself has support for OpenSSL, but also like for the platform-specific backend, meaning if you are running your application on macOS or on Windows, it will utilize whatever the OS in itself provides as security APIs. Or you can use OpenSSL. But these days, there's more and more solutions coming up, and depending on your scenario and use case, you also might want to utilize another SSL solution. So that is something we are aiming to implement as well, that you are capable of using your Qt application like you have been using before, but then are able to basically exchange the security layer underneath. There's way more changes when I could go in here, and I just wanted to highlight a couple of well, one could call them tiny, but as we all know, these things do sum up. So overall, those could be categorized in making things faster, meaning the performance aspect, but also when it comes to modernizing our API, meaning under the category of convenience, etc., etc. So there has been many changes happening here as well. I've been using the term ecosystems beforehand already, but there's two things I would like to highlight still, and that is C++ as well as CMake. As I said in the introduction, C++ 17 is currently one of the most used C++ versions. And when we look at how fast the language in itself is already evolving, we needed to take a balancing act on what's the minimal version we want to introduce with Qt 6.0. We could have gone with C++ 20 as well, but we also have seen that not necessarily all application projects out there are already on that standard. And C++ 17 has already reached quite a lot of adoption, which is why we have been seeing that as the best fit for 6.0 to bet on or to require C++ 17 when as a system in itself. For you who have been using Qt now for quite some while, you might remember that we have QMake, which is its own build system for Qt itself, but also for Qt users. But overall, the situation as such is that CMake has established itself as the C++ industry standard build system in itself. And for that reason, and also when it comes to supported features and maintenance effort, etc., from both angles, that being maintaining Qt in itself, so that is like internal or in-house usage, but also for the Qt users out there, it's much more convenient and beneficial to use then also CMake as the build system to compile and configure Qt in itself, because when you're not like into two different build tools depending on your current effort or what you want to achieve. So with Qt 6, you are now able to build Qt itself based on CMake. But having said that, if you are using QMake in your project right now, be assured that QMake is still there for application purposes, meaning we will also continue supporting QMake for the application case, but we would really encourage you to consider CMake sooner or later. I've been now talking quite a lot on the framework in itself, but let's also have a look into the tooling, which, well, basically it's two items: developer tooling, meaning Qt Creator, but also Designer, which I will go to in the next slide. On the Qt Creator side, we would like to highlight that you can use Qt Creator already to get started with Qt 6 and develop applications based on Qt 6, that being with CMake or QMake build systems that both do work. Obviously, also the Creator in itself is an IDE which is having quite a lot of improvements on its own as a tooling, but be assured that Qt 6 is supported with that version. And the very same also applies to the Design Studio, with the minor difference that Qt Design Studio 2.0, which is about to be released, will have support for Qt 6. We are highlighting the Qt 6 support here, but that also still means that with Design Studio, you're capable of creating then user interfaces for Qt 5 as well as Qt 6. So the Qt 6 support has been added in addition to the Qt 5 support. That also implies all the various bridges we have in Design Studio, meaning like Photoshop, Sketch, and then Figma, etc. All these imports are supported both for Qt 5 as well as Qt 6 once you go through Design Studio to implement that. So that's a very, very brief overview of what has been happening, and also going into a bit of the desktop specific assets here. If you are now interested, and I hope you really are, there's a couple of pages I would like to highlight, and then also other items in regards of the migration in itself. So overall, each of the modules will have a porting guide, meaning which are the use cases or the API changes we have been doing where you will need to adapt your application. So generally there's two scenarios. One is that we have been introducing a new API, which you can use concurrently, like the property system, but also there's scenarios where we needed to replace some API, and you will find these documented in these porting guides. So, but whenever you do need to figure out, okay, here's now when I want to compile against Qt 6, where there's an error which I don't understand or anything alike, you will have some guidance there. We're also looking into the features like tooling based on Clazy, and in regards of that, it can go through your source code and tell you, okay, this is like the things you really should look into. In Qt 5, we already started to provide deprecation warnings for quite a couple of APIs. So you could already look into the effort estimate, but with that tooling, we also hope to help you in speeding up the overall migration process. In addition to that, I would also like to highlight that it's still possible, and that is also something we have been doing in, for instance, Creator beforehand, to have a project compile against both versions. So you can do version checks which Qt version you're compiling against, and then either use the old or the new API, or in most cases, the API has just stayed the same. So this is really like only the libraries you're linking against. If you are interested in any further help when it comes to the migration support, we also do provide workshops from the Qt company, but also from our partners. In that respect, I would just ask you to get in contact with us. We can help you out with that. And with that having said, thank you very much for listening in. And now let's start the Q&A session.